Let's be real. We've all wondered why the software we use every single day can still be so glitchy. Well, there's a quiet revolution happening right now in how we find and fix those bugs. And yeah, you guessed it, it's all thanks to AI. Today, we're diving into how large language models are turning into the ultimate bug hunters.
Oh, you know the feeling. You download that new app, you're all excited to try it, and bam, it crashes. Or some key feature just flat out doesn't work. It is a universal frustration for sure. For decades, developers have been fighting this battle, but the old methods, well, they have their limits. That's the problem we're going to unpack, and then we'll see how AI is offering a pretty powerful new solution.
So here's our game plan for this explainer. First, we'll dig into the hidden weaknesses of traditional testing. Then we'll meet our hero, the AI coder. After that, we'll look at exactly how it's testing code today, we'll be honest about its current blind spots, and finally, we'll take a peek into the future of what could be bug-free software.
Okay, so to really appreciate what's new, we have to understand the old problem. See, the traditional ways of testing software are absolutely critical, but they often have a major flaw. They don't have a deep understanding of what the code is actually supposed to do.
The foundation of all of this is something called unit testing. You can think of it like this. Before you build a house, you check every single brick, right? Make sure it's not cracked. Unit testing does the exact same thing for the smallest little pieces of code. It's totally fundamental, but how you check those bricks makes all the difference in the world.
And this slide right here perfectly illustrates the core issue. The old structure-driven way was basically a grammar checker. It could tell you if a sentence was formed correctly, but it had zero idea if the story made any sense. The new AI-powered way is semantics-driven. It's like a story editor that actually reads the code and understands the plot, what the developer was trying to achieve.
And this is where large language models, or LLMs, come in and just completely change the game. They don't just read the code's grammar, they understand its language, its context, and its purpose.
And hey, don't just take my word for it. This comes straight from the source research. The key phrases to grab onto here are code semantics and programming patterns. Because LLMs have been trained on literally billions of lines of code, they've learned all the unspoken rules, the common ways developers solve problems, and what a piece of code is really supposed to be doing.
This right here is the big unlock. The AI isn't just mindlessly matching patterns, it's actually comprehending intent. And by going beyond simple error checking to understanding a developer's goal, it can create way smarter and more realistic tests.
Okay, so that's the why. Now let's get into the how. What are researchers and developers actually doing with this technology, like, right now?
And the insights we're about to cover, well, they aren't just based on one or two little experiments. The source for this deep dive is a systematic review of 115 different scientific papers. So yeah, this gives us a really comprehensive look at the entire field.
You know, the whole process really boils down to two main phases. First, you've got the generative phase. This is where the AI takes its first shot at writing the tests. But, and this is the cool part, it doesn't stop there. Then comes the quality assurance phase. The AI actually runs the test it just wrote, sees if it fails, and then automatically tries to repair and refine it. It's this constant loop of writing, checking, and fixing its own work.
So how do you get the AI to even start this process? Well, the dominant technique by a long shot is called prompt engineering. It's basically the skill of asking the AI the right questions and giving it the right context so it can generate the best possible tests right from the get-go.
And the data, well, it shows just how dominant this one approach is. According to all that research, a staggering 89% of the studies in this field rely on prompt engineering. It's flexible, it's powerful, and right now, it is the undisputed king of AI test generation. No question.
But, you know, no technology is a silver bullet, and it's important to be realistic here. While these LLMs are incredibly powerful, researchers have pinpointed a couple of really critical areas where they still need to get a whole lot better.
The two biggest challenges on the table right now are weak fault detection and a serious lack of standardized benchmarks. Let's break down what that actually means in plain English.
Weak fault detection is the big one. What it means is the AI is fantastic at writing tests that compile and run without any errors, but it's not quite a master detective yet. It can sometimes completely miss those subtle, tricky, logic-based bugs, the very ones that cause the biggest headaches for users down the line. But here's the cool part. Knowing about these challenges allows researchers to actually chart a course for the future. They've laid out a pretty clear roadmap for how this technology is going to evolve from a helpful tool into a truly autonomous system.
And here's what that progression looks like. Right now, today, we have the AI as a co-pilot, guided by human developers using prompt engineering. In the very near future, we're going to see hybrid systems that combine that amazing semantic understanding of LLMs with the super rigorous structured approach of traditional tools. And then, out on the horizon, fully autonomous agents that can test, find bugs, and maybe even suggest the fixes all on their own.
So, to kind of sum up the path forward, the goal is to build those autonomous agents, create hybrid systems that really cover all the bases, and this is so crucial, develop standardized benchmarks. That way, we can actually measure progress and know for sure which AI models are the best bug detectors out there.
It all leads to one really fascinating question. For developers, the whole process of writing and testing code has always been this deeply human thing. But as this technology gets better and better, you have to wonder, in the near future, will the most valuable member of a software team not even be a person at all?